Okay, this video is on radicals and simplifying radicals. And when you're working with radical expressions, taking a square root or a cube root, there's three pieces to this expression. And the first piece is the number here that goes kind of in the little V part of the radical symbol. And this number here is called the index. The number that's underneath the radical symbol, the number or the expression, is called the radicand. And then the number that the radical expression is equal to, that's called the root. So when we are looking at an expression, like for example this expression right here, square root of 81, first thing I notice is that there's no number here. So you might be tempted to say, oh well, this radical expression doesn't have an index. Actually it does. If you've got a radical symbol and it doesn't have a number here where the index goes, that number is assumed to be a 2. So even though there's not actually a 2 written here, there's kind of an implied 2 there. So we know this is a square root of 81. So when we say the square root of 81, we know that the square root of 81 is equal to 9. And the reason we say the square root of 81 is equal to 9 is because 9 times 9 equals 9 squared, which is equal to 81. In other words, the index tells you how many times you have to multiply the root times itself in order to get the radicand. So in this case, my root is 9. I have to multiply 9 times itself 2 times in order to get it to be equal to the radicand. That's what it means to take the square root of 81. Let's take a look at a cube root problem. Here we're trying to find the cube root of 64. Well, I know that the cube root of 64 is going to be 4, because if I multiply 4 times itself 3 times, that is 4 times 4 times 4, or 4 to the power of 3, then I know 4 times 4 is 16, and 4 times 16 is 64. So again, 4 is the number that if I multiply times itself 3 times, it's equal to the radicand, which is 64. The fifth root of 32x to the fifth. All right, so now our radicand is not just a number, it's an algebraic expression. Well, the fifth root of 32x to the fifth power is going to be equal to 2x, and again, that's because if I multiply 2x times itself 5 times, that is 2x times 2x times 2x times 2x times 2x, that's the same as 2x raised to the power of the index, raised to the fifth power. And 2x to the fifth power would mean 2 to the fifth power times x to the fifth power. And 2 to the fifth power is 32, so that would give me 32x to the fifth, which is my radicand. Now in your notes you have some problems there where it talks about using your calculator to find different roots, and we're going to go over that a little bit in class, but for the rest of this video we're going to talk about doing these by hand, that is finding the roots of different radical expressions by hand when the expressions may not be quite as simple as these. So this is what we call taking a radical expression and putting it in simplest radical form. So this example that you see in your notes, example 1, asks you to find the cube root of 24. Well, this looks like it might be a problem because I need a number that I can multiply times itself 3 times to give me 24. Well, if I take 2 and multiply it times itself 3 times, 2 times 2 is 4, 2 times 4, that gives me 8, so that one's not going to work. If I take 3 and multiply it times itself 3 times, 3 times 3 is 9, 3 times 9 is 27. Well, 8's too small, 27's too big. It looks like my number is going to be somewhere between 2 and 3, so it's not going to be a whole number. Well, the way we approach problems like this is we want to use factor trees in order to find what's called the prime factorization of 24, and then we can pull out any perfect cube factors that we find using our factor tree. So let's see what that looks like. 24, if I want to factor 24 using a factor tree, I just ask myself, well, what are two numbers that will multiply together to give me 24? How about 2 and 12? So 2 times 12 gives me 24. The number 2, I can't break that down anymore. It doesn't have any other factors besides 1 and itself, so this is a prime number, so I'm done with this one. 12, however, I can break that down some more. I can break that down into, how about 2 times 6? Again, 2, I can't break that down anymore because it's prime. 6, however, I can break down into 2 and 3. And all of these numbers here, these numbers make up what's called the prime factorization of 24. That is to say, 24 is equal to 2 times 2 times 2 times 3. 2 times 2 times 2 times 3. Or I could write that as 2 to the third power times 3. Now if I go back and rewrite this expression, instead of saying the cube root of 24, I say the cube root of 2 to the third power times 3. Well, now I can see that one of my factors here, 2 to the power of 3, that's what we call a perfect cube factor. That is 2 to the third power. The power of this factor matches the index of my radical expression. So I can take this and I can pull it out from under the radical. So if I pull that 2 cubed out from under this cube radical, that means outside the radical that's going to be 2. That is, the cube root of 2 cubed is equal to 2. So I pull that 2 out from under the radical, that means I'm left with 3 underneath my radical sign. And the simplest radical form of the cube root of 24 is 2 times the square root of 3. So this kind of illustrates the steps that we go through when we're doing simplest radical form, when we're putting a radical expression in simplest radical form. Step 1 is we use a factor tree to find the prime factorization of the radicand, in this case 24. Step number 2 is we pull out any perfect square or perfect cube or perfect whatever factors that we have underneath the radical. In this case, we had one perfect cube factor that we could pull out. And finally, step number 3, any remaining numbers or sometimes variables, as we're going to see in a minute, any remaining numbers or variables stay inside the radical. So let's take a look at a couple more examples.